Okay students, now let us discuss here the theory of AC generator. So already we have discussed the construction and working of AC generator. Now here we have to discuss its theory. That means what? We have to derive the expression for the induced EMF. Expression for what? The induced EMF and the induced current in AC generator. Right? So this is also very important question for 5 marks to discuss the theory of AC generator. And it is a introduction point to what? The next chapter, alternating current. So this is also very important point to discuss the next chapter, that is the alternating current. So before going to the detailed discussion of the theory, just now I will give some introduction about what the types of AC generators. So you all know that in power generators, armature is rotated by using some mechanical energy, and depending upon what the type of mechanical energy used, we have the different types of power generators here. Alright. So one is hydroelectric power generator. Hydroelectric power generator. Hydroelectric power generator. So here water is used to rotate the armature, and hence that mechanical energy is converted into what? The electrical energy. That is what hydroelectric power generator. Again again one more is what? The thermal power generators. The thermal power generator, and one more is the nuclear power generator. Nuclear power generator. So depending upon the type of mechanical energy used to rotate the armature, we classify here the power generators. That is what AC generator, what here? Hydroelectric power generator, thermal power generator, and nuclear power generators. So this is the very important point here. And what happens here in most of the generators, what happens here in modern days, the coils are held stationary, and the electromagnets which are rotated, and the frequency of the rotation is 50 Hz in India. The frequency of rotation is 50 Hz in India, and in some other countries such as USA this is 60 Hz. This is in India. India frequency of rotation is 50 Hz. The frequency of AC in India is 50 Hz, and the frequency of AC in USA is 60 Hz. Right? This is the one of the important point you have to note down here. Right? So with this discussion, now let us start here the theory of AC generator. Let us derive here the expression for the induced EMF. So now you all observe here the figure, which consists of what here? A rectangular coil. Rectangular coil means what here? The armature, right? Which consists of what here? The front view of the coil is shown here. This is what here? This is a coil. That is called as what? The armature, right? Which consists of what here? Armature, and these two are the what here? Magnets are used to produce the magnetic field, right? Now let us derive the expression here. Let A be the area of the coil. That cross-sectional area of the coil is, or the armature is A. Let A be the area of the coil. That means armature. Let A be the area of the coil or armature, cross-sectional area of the rectangular coil or the armature, and N is the number of turns used in the armature. N is what here? The number of turns. N number of turns used in the coil, and B is the magnetic field. B is what here? Which is the magnetic field. B is the magnetic field, and theta is the angle between A and B. That means what? Area of the coil, normal to the area of the coil, and the magnetic field. So theta is the angle between area of the coil, that is normal to the area of the coil, and magnetic field D, right? Theta is what here? It is the angle between the magnetic field and normal to the area of the coil. That is called as what here? Theta. And initially that coil is held perpendicular to the magnetic field. So initially that theta is equal to 0 degree, right? Now omega is the constant angular velocity. Omega is what? Constant angular velocity of the rotation of the coil. That coil is rotated with a constant angular velocity omega. Omega is constant angular velocity of the rotation of the coil. Constant angular velocity of the rotation of the coil. That means what? The coil is rotated with a constant angular velocity omega. Therefore, we can write here theta is equal to omega into t, right? Because of what? Omega is the angular velocity. Angular velocity is equal to what? Angular displacement divided by t, right? Therefore, theta is equal to omega into t here. So this is the description about the diagram, right? A is the area of the coil, cross-sectional area of the coil. N is the number of turns used in the armature, that is the coil, and B is the magnetic field, and theta is the angle between normal to the area of the coil and the direction of the magnetic field, and omega is the constant angular velocity of the coil with which it is rotated. So hence we can write theta is equal to omega into t. So now we can write here by the definition of the magnetic flux. The magnetic flux linked with the coil at any instant of time t, that can be written as what here? So with this discussion, the magnetic flux will link with the coil at any instant of time t, that can be written as what here? The magnetic flux linked with the coil at any instant of time t is given by, at any instant of time t is given by. So magnetic flux linked with the coil, that can be written as what here? So pi is equal to B into A, that is the definition. So N is the number of turns used in the coil. Therefore pi is equal to N into B into A. And again here cos theta, right? BA cos theta, it is our definition of magnetic flux, but N is for, that is for one turn. Here N number of turns, so it is equal to NBA cos theta. But theta is equal to what here? Omega into t, right? Therefore it is equal to what we can write here? NBA cos omega t, right? NBA cos omega t. Now this is the magnetic flux linked with the coil here, and what happens here? As the coil is linked with the magnetic flux, which changes here when the coil is rotated in a magnetic field, right? So magnetic flux linked with the coil changes, and hence EMF is induced in the coil according to Faraday's law of electromagnetic induction. What we can write here? So the phenomenon of EMI happens here, right? Whenever the coil is rotated in a magnetic field, the magnetic flux linked with the coil changes, and hence EMF is induced in the coil here, right? So therefore, according to Faraday's law of electromagnetic induction, the induced EMF is given by, so this is the flux. The flux linked with the coil changes when it is rotated in a magnetic field. The flux linked with the coil changes, right? The flux linked with the coil changes when it is rotated in a magnetic field, right? When it is rotated in a magnetic field. Therefore, the induced EMF, flux linked with the coil changes when it is rotated in a magnetic field. So now the induced EMF is given by, according to Faraday's law. According to Faraday's law of electromagnetic induction, the induced EMF is given by E is equal to minus d pi by dt. The rate of change of magnetic flux linked with the coil, right? The induced EMF is depends upon what? The rate of change of magnetic flux linked with the coil here. Now let us substitute the value of pi. So what we have written here, pi is equal to nVA cos omega t. Let us substitute here. E is equal to minus g by dt of nVA cos omega t. Right? Here n is constant, b is constant, and a is constant. Now let us take it outside the bracket. So what we can write here? Minus nVA d by dt of cos omega t. So what is the differentiation of cos omega t here? Right? Differentiation of cos omega t is minus omega sin omega t. Right? Therefore, what we can write here? Induced EMF is equal to the differentiation of cos omega t is what? Minus nVA. The differentiation of cos omega t is what? Minus omega sin omega t. So minus omega sin omega t. Therefore, finally, what we can write here? Induced EMF is equal to nVA omega sin omega t. Right? So this is the induced EMF in a coil. And this bracket nVA omega, where n is the number of turns, b is the magnetic field, a is area of the coil, and omega is the angular velocity. Now this value changes, omega into t changes here. The theta value changes. Based on that, we have to write the value of induced EMF here. Right? So this nVA omega, this is called as the peak value of the induced EMF. Peak value means what here? The maximum value of the induced EMF. Right? The maximum value of the induced EMF. So that can be written as what here? Right? Here nVA omega, it is called as the peak value of the induced EMF or the maximum value of the induced EMF. This is equal to what? It is denoted by E naught. Right? Therefore, by substituting this value, nVA omega is equal to what? E naught. So E naught is equal to what? The peak value of induced EMF. Peak value of induced EMF. Peak value here, this is the maximum value of the induced EMF in a coil. Right? Peak value of the induced EMF, that E naught is equal to what here? NAB omega. So at what value this occurs here? That means sin omega t value is maximum. That means omega t's value is maximum. Sin value is maximum, that is plus 1 and minus 1. So theta value. So sin theta value maximum maximum value is plus 1 and minus 1. So yavaga sin omega t value, when sin omega t value is plus 1 and minus 1 bರ್ತದೆ, ಆ ಕೇಸ್ ಒಳಗೆ ನಮಗೆ ಏನಾಗ್ತದ್ರಿ maximum EMF induced, maximum value of the induced EMF you will get here. ನಮಗೆ ಯಾವಾಗ maximum value of the induced EMF ಬರ್ತದ್ರಿ, when sin omega t value is plus or minus 1 ಬಂದಾಗ ಮಾತ್ರ ನಮಗೆ ಏನಾಗ್ತದ್ರಿ maximum EMF induced ಆಗ್ತದೆ. So by this equation what we can write here, the expression for the induced EMF is equal to E into E naught sin omega t. So this is the final expression for the induced EMF here. Right? So this is the final expression for the induced EMF. That is E is equal to E naught sin omega t. Right? So this is the expression for the induced EMF. This is the expression for the induced EMF in AC generator. This is the expression for the induced EMF in AC generator, and this is also called as the sinusoidal EMF. That means what? So according to the sine wave graph, the value of the EMF changes here. So that's why it is also called as what? The induced EMF is also called as the sinusoidal EMF. Now I will briefly in 2 minutes I will explain it once again. Let us see here. So this figure consists of what here? We have a rectangular coil. It is consists of what? N number of turns. A is the area of the coil and B is the magnetic field, and theta is the angle between the normal to the coil and the magnetic field, and omega is the constant angular velocity with which the coil is rotated. Therefore theta is equal to omega into t. Angular velocity is equal to what? Angular displacement divided by time. Therefore angular displacement is equal to what here? Omega into t, right? So when this coil is rotated in a magnetic field, the magnetic flux linked with the coil changes and hence EMF is induced in the coil, right? So the magnetic flux linked with the coil is pi is equal to, for n number of turns, n BA cos theta, but theta is equal to omega into t, right? So according to Faraday's law of electromagnetic induction, the induced EMF can be calculated by using this expression. So substitute the value of pi here, right? So pi is equal to n BA cos omega t, right? So these three terms are constant here. N BA, take it outside, right? The differentiation of cos omega t is what? Minus omega sin omega t. Therefore this minus into minus plus, so n and hence what we will get here? N BA, this omega, and again sin omega t. And this n BA omega, this is called as what? The maximum value of the induced EMF or the peak value of the induced EMF. Let us represent it graphically also, right? N BA omega is equal to E naught. This E naught is called as the peak value of the induced EMF. That E naught is called as what here? The peak value of the induced EMF, or it is also called as what here? The maximum value of the induced EMF. Therefore E is equal to E naught sin omega t. So this expression is called as what? The expression for the induced EMF in case of AC generator, and this is also called as what here? The sinusoidal EMF. So this is the very important expression, and the derivation you have to remember here to discuss the next point, that is what? The alternating current, right? Now let us write the expression for the induced current, and let us represent it graphically also. So expression for the induced current. So now as we have derived here the expression for the induced EMF. So expression for the induced EMF is equal to what? E is equal to E naught sin omega t, right? E is equal to E naught sin omega t, where E naught is the maximum value of the induced EMF. So by induced current, how we can write here? From the Ohm's law, right? If R is the resistance of the coil, then induced current can be written here by using the Ohm's law, right? If R is the resistance of the coil, 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 so by Ohm's law, the induced EMF can be written as what here? Right? Induced current can be written as what here? I is equal to E divided by R here. Right? V is equal to I into R. Therefore, from that law, what we can write here? Induced current is equal to E divided by R, and this is equal to E is equal to E naught sin omega t divided by R. So this E naught divided by R is equal to what here? This is I naught. That means what? The peak value of the current or the maximum value of the induced current, right? Therefore I is equal to I naught sin omega t. So this is the expression for the induced current, and this is the expression for the induced EMF. Here E naught is equal to N BA omega, right? This is known as the maximum value of the induced EMF, and this E naught divided by R. So I naught is equal to what here? E naught divided by R, and this is called as the peak value of the current, right? This is peak value of EMF, right? peak value of the induced EMF or the maximum value of the induced EMF, and this is called as peak value of induced current. Peak value of induced current. So these two are the important expressions, that is the expression for the induced current and the expression for the induced EMF and the expression for the induced current, right? So in both the expressions, right, in expression E is equal to E naught sin omega t and I is equal to I naught sin omega t. So we have the sin A functions here, that is sin omega t and cos omega t. Therefore the value of sine function, right, the value of sine function varies from +1 to -1, right? The value of the sine function varies from what? +1 to -1. Therefore the polarity of the induced EMF or the induced current also changes with respect to time here, right? So the direction of the induced current also varies periodically, and hence it is called as the induced current is called as what here? The alternating current. Why we call here the induced current is alternating current here? Because the sin A function value changes from what here? +1 to -1, right? Therefore the polarity of the induced EMF also changes with respect to time here, from +1 to from plus to minus again here. Therefore the direction of the induced current also changes here with respect to time. Therefore this induced current is called as the alternating current. What is meant by alternating current? It changes its direction periodically. That is called as alternating current. Now let us represent here the induced EMF graphically, right? Now let us represent here the induced EMF graphically. So then how to represent the induced EMF graphically? That is sinusoidal EMF, that is the graphical representation of EMF. So the induced EMF E is equal to E naught sin omega t. This is the expression what we have got here. But omega is equal to what? 2 pi nu. That is, nu is the frequency of rotation of the coil, right? Nu is the frequency of rotation of the coil here. Frequency of rotation of the coil. Frequency of rotation of the coil, and here T is called as time period of the coil. That means what? Time required to rotate the coil for one rotation. One rotation agle coil gets the time beku, that time is called as what here? The time period, and nu is what here? The frequency of rotation. So from these two values, E is equal to E naught sin 2 pi by t, what we are written here. So here we have to draw the table here with these two values. It is the time, and one more is what? The value of theta. Theta value change ಆಗ್ತಿರ್ತೈತ್ರಿ ಮತ್ತು time ಎರಡು ವೇರಿಯಬಲ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನಾವು ಗ್ರಾಫ್ ಪ್ಲಾಟ್ ಮಾಡ್ತೀವಿ, right? When t is equal to 0, t by 4, t by 2, 3t by 4 and t. So right, ಯಾವಾಗ time equal to t equal to 0 ಇರ್ತದೆ, coil perpendicular to the magnetic field ಇರ್ತೈತ್ರಿ. That means initially theta is equal to 0 degree, time t is equal to 0, EMF induced equal to ಕೂಡ ಏನಿರ್ತೈತ್ರಿ 0 ಇರ್ತೈತಿ, right? Initially induced EMF is equal to 0 when the coil is not rotated. Coil rotate ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ induced EMF ಏನಾಗಂಗಿಲ್ಲ, induced EMF equal to 0 ಇರ್ತೈತಿ. ಯಾವಾಗ coil rotate ಆಗಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ for a time t by 4, right? 1/4 of the rotation ಆದಾಗ ಏನಾಗ್ತೈತ್ರಿ, it covers an angle 90 degree rotate ಆಗ್ತೈತ್ರಿ coil. So 90 degree rotate ಆದಾಗ ಏನಾಗ್ತೈತ್ರಿ, in a time t by 4, pi by 2 angle covered and induced EMF is plus E naught. So ಅವಾಗ ಏನಾಗಿದೆ ನೋಡಿ, ಇಲ್ಲಿ ಬಂದಿದೆ. So this is what the maximum value of the induced EMF. This is what plus E naught, right? Again when it covers an angle in a time t by 2 ಅಂದ್ರೆ half rotation ಆದಾಗ ಏನಾಗ್ತೈತೆ ನೋಡಿ, which covers a 180 degree ಆದಾಗ ಏನಾಗ್ತೈತೆ ನೋಡ್ರಿ again, right? So again at time t by 2 the EMF is gradually decreases and again it becomes 0 at pi by 2. Pi by 2 value ಬಂದಾಗ ಮತ್ತೆ 0 ಆಗ್ತದೆ. ಇಲ್ಲಿ ಬಂದ್ಮೇಲೆ ಮತ್ತೆ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತದೆ ನೋಡಿ, right? That is 3t by 4. At a time 3t by 4, 3/4 of the one rotation, that angle covered is 270 degree angle rotation angle cover ಮಾಡಿರ್ತದ. ಅವಾಗ induced EMF ಏನಾಗ್ತೈತಿ, is equal to minus E naught. right? It becomes what? The induced EMF is minus E naught. The polarity is changed here, right? This is the peak value of the EMF. This is the maximum value of the induced EMF plus E naught, and this is the maximum value of the induced EMF, but polarity is changed here, right? Again, when it covers one rotation, 180 degree at 360 degree, one rotation complete again it comes to original position, right? In this way, this process is continuous here. The polarity of the induced EMF changes periodically. That means the polarity of the induced current also changes periodically, and hence this induced current is called as what here? The alternating current. So this is the plus E naught, and this is what here? The minus E naught. The same graph we have to represent for this is induced EMF, or what we can write here? I naught. This is plus I naught, and this is minus I naught. The same expression for the same graph we have to represent for the induced current also. So this is the brief introduction about the graphical represent. So the totally in this video class, what we have discussed here, initially we have started with the theory of the AC generator, right? Well, with the theory of AC generator, we have arrived the expression for the induced EMF. From the induced EMF, we have derived the expression for our induced current also. And this is finally the graphical representation of the induced EMF or the induced current, that is alternating current. Why it is called as alternating current? It changes its polarity. That is, sign of the induced current changes periodically. So that's why it is called as the induced current, right? It changes its direction periodically. So that's why it is called as the alternating current. So this is about the theory of AC generator, and we have arrived the expression for the alternating current and alternating EMF, right? Okay. In the next video class, we will discuss the next points related to the topic. Okay. Thank you, students.